Okay, so hi everyone, and welcome to our CS284A final project. Um, for our final project, we decided to simulate and render a 3D lava lamp. And so there were three main components to this. The first thing we did was to implement a fluid particle simulation. So each particle is represented as a sphere with a certain density, which will then cause the particle to rise or fall when its density is lower or higher than the surrounding liquid. And so this density will get lower as the particle is at the bottom of the lava lamp, simulating that it's getting hotter, or it'll also get higher when it's near the top of the lava lamp. And we also implemented collisions during this part, which you can see here in this simulation. And so the next step was to implement blobs, which is just a set of fluid particles, and also allow them to merge and split. So to do this, we used connected components in an undirected graph in order to detect that once two particles were at a certain distance threshold, it would then form a blob. And so you can see in the simulation here how the colors are changing, and each color basically just represents its own blob. But do note that the colors we have here are random. And so finally, the last step was to actually render the blobs so that we can go from individual particles to an enclosed set. And so to do this, we used the matching cube algorithm, which basically will divide up the space into smaller cubes and sample each cube for its relationship to the surface. And if so, the triangles are then generated, which can then be connected to form a final mesh. So this essentially allows us to reconstruct a surface from our particle simulation and have a more realistic looking lava lamp, which you can see here. And yeah, that's about it. Thanks for watching.